All right, so welcome to the 25th lecture on NLP. So today we will wrap up our discussion on NLP in this course. Um, so we have spent the last 3.5 months on various topics on NLP, starting from the very basics to modern day NLP involving large language models. So today I will try to summarize again the use of large language models in practice. We had covered some of that in the last lecture as well when I talked about pre-training and post-training. So I'm going to revisit that and then follow it up with in-context learning and fine-tuning and prompt-based fine-tuning, because these are the parts that you most probably be using in your practical life. So it would be kind of a refresher as well as some extensions of what we have already discussed. And I think that would be basically the end for this course. There are other topics that I could have covered, but I think it's appropriate to stop here. Obviously, NLP is quite vast, including modern day NLP, as well as there are some traditional topics that are still very important that we have not covered. But I think this is good enough for you guys to continue your exploration in NLP as well, in theory as well as in practice. Um, so that's the plan for today. So any questions? So we have our last quiz on Wednesday, a couple of days from now. So that will be in class. So I will be present in class as well. So we will not have an online lecture. So we'll meet in class on Wednesday. And then as scheduled, we will have a project presentation session on Sunday. Okay. Your exam, of course, is on, if I'm not mistaken, December 19. So actually in the Wednesday's lecture, I'll also go over what is the exam as well. So what is included and what's not included in the exam. So essentially only a few things that we did pre-mid would be excluded. The rest would be present because of continuity. So we'll keep some of those for continuity, but things like chapter 2 and maybe part of chapter 3 might be excluded from the textbook, and maybe a discussion on logistic regression, but the rest would be included. So in fact, I will discuss that on Wednesday. Okay. So any questions? So are you seeing my screen? Okay, I think so. Yeah. Okay. So modern day NLP is based on transfer learning. So we mentioned this before as well. So transfer learning is a cornerstone in modern day NLP as well as in modern day machine learning. So what is transfer learning? You train a model maybe on some generic task and then you adapt it to your own personal task. So that is transfer learning. In other words, you are learning from generic things and maybe then using that generic information for your specific application. So in the context of NLP, we have what is known as pre-training. We talked about this last time. And we have post-training. And for most large language models that are out there, this is usually done by the designers of the large language models. Unless, of course, you are a big company and you have the resources to do pre-training as well as post-training on those large models, you can do it on your own. But usually most companies wouldn't be able to do it on their own because of the size, the memory and compute resources that are required to uh, pre-train as well as post-train, let's say the large models that are available today, GPT-4, GPT-5, Claude 4.5, Llama 4, and maybe Copilot and so on. So there are tons of them out there would be very exponentially high. So usually these would be done for you by the company who develop these products. So pre-training is, of course, training on language and using the appropriate loss function. Post-training is then trying to adapt that model to be more general. So we talked about two things in post-training. So instruction tuning, and then we also talked about preference alignment. So this is post-training. And again, both of these would typically be done by the designers of the models. End users would most likely not do this. Of course, they can do it if you have a smaller model, a quantized model, a smaller model. But usually this will be done by the designer. So instruction tuning is kind of training the model to respond to instructions. And that is how we mostly use our large language models today. So if this was not done, if instruction tuning was not done, तो आप जो आप जीपीटी पे जाते हैं, चैट जीपीटी पे जाते हैं या लामा यूज करते हैं, वो उस तरह आंसर्स नहीं देगा जिस तरह वो अभी दे रहा है. So this is all because of instruction tuning. So it has been trained to recognize prompts and questions and different tasks and then respond to those. And then preference alignment is further fine tuning using reinforcement learning, trying to distinguish between multiple answers. So, and of course, this is used to kind of adapt to try to adjust issues like security and safety and prevent harm from large language models. Okay. Okay. Now coming to how end user would use these models. So there is a lot of variety here. So I've tried to kind of uh, compile it into broad terms. So one is in context learning. Okay. So in context learning involves no parameter adaptation. Okay. So no parameter adaptation. So we will discuss this shortly. And then the second broad category that I mentioned is called fine tuning. So this does involve parameter adaptation, but there's a lot of variety here. So you have standard fine tuning, you have prompt-based fine tuning, and within prompt-based fine tuning, there's a lot of options available. Okay. So parameters are adapted, but uh, limited number of parameters. Okay. So this would be the scenario that most people would be using in their companies and so on, either using in context learning or using fine tuning. Standard fine tuning, which is also sometimes quite expensive, or prompt based fine tuning or prompt tuning. Okay, so let's look at these very quickly. So I prepared actually these slides from GPT and then adjusted them a little bit. ठीक है तो so chat GPT and also helping out creating content, but most of this stuff or some or majority of this stuff you can find in a textbook also. All right, so let's go over this, and of course the formatting and some maybe minor issues हो सकते हैं, मैंने वैसे देखा हुआ है, but mostly it's okay, कोई issue नहीं है इसमें slides में. So okay, what is in context learning? So there is no adaptation of the model. You have a adaptation, you have a model, and then you simply give some instructions to it, and we call that instruction a prompt. So similarly, simply by conditioning on your prompt or instruction, the model responds to it, and depending on whatever instruction you have given or whatever prompt that you've given, it will be able to answer your question. So in other words, it's utilizing the already pre-trained information in its model to answer your questions. And pre-trained मीन प्री ट्रेनिंग प्लस पोस्ट ट्रेनिंग एज वेल, बिकॉज उन्होंने इंस्ट्रक्शन ट्यूनिंग भी की हुई है, प्रेफरेंस अलाइनमेंट भी की हुई है, आप सिर्फ उसके ऊपर एक प्रॉम्प्ट दे रहे हैं। एंड ऑफ कोर्स उस प्रॉम्प्ट से पहले एक सिस्टम प्रॉम्प्ट भी हो सकता है जो आपको पता नहीं है यूजली। सो मोस्ट लार्ज लैंग्वेज मॉडल्स हैव ए सिस्टम प्रॉम्प्ट, जो इंस्ट्रक्शंस होती हैं जो एलएलएम को जा रही हैं बिफोर यू इवन गिव योर ओन इंस्ट्रक्शंस, and then the LLM uses this as context or condition the response on this, and it's able to give a good response because it has been instruction tuned. ठीक है? So simply you are using the LLM basic process, so generating one word at a time. So the context that you're given would help it generate the best information. So that is guiding the generation. ठीक है? So again, nothing that changes within the model, only your prompt is changing the output of the model. Okay? So obviously you can use whatever prompt and try to solve whatever problem that you have in mind. And in most cases, because of the instruction tuning that has already been done, it is able to give you a good answer. ठीक है? Even for example, let's say आजकल आप मैथ की प्रॉब्लम्स आराम से सॉल्व कर सकते हैं, प्रूफ सॉल्व कर सकते हैं. 2 years back this was not possible by simple ICL. Why? Because it has already been uh, instruction tuned on such kind of problems. इसके अंदर फिर दो सिनेरियोज आते हैं. यू हैव जीरो शॉट लर्निंग एंड देयर इज ए फ्यू शॉट लर्निंग. अगेन लर्निंग का नाम यूज हो रहा है बट अडाप्टेशन नहीं हो रही ऑफ द मॉडल, बट अडाप्टेशन ऑफ द आउटपुट हो रही है based on just the context. And some in the literature you will see that this process of how model adapts theoretically to the depth is not very well understood. Of course, it's understood contextually because condition probability जब आप generate करते हैं, condition change करते हैं तो generation change हो जाएगी. ठीक है? We already know that. But internally जो उसकी complexities हैं, they are not known to a very great detail. ठीक है? So you can think of this as a research area as well. ठीक है? So in zero shot learning, the model just receives an instruction. So there are no examples that are given in the prompt or in the context. So you can write whatever you want. So let's say you want to translate a word hello to French. You just write that and output bonjour. So this is following instructions and without giving any explicit examples. Okay? So this would work well in most cases because the model has already been instruction tuned beforehand. Okay? For such task. So in few shot learning, you give explicit examples in the prompt. Okay? And this would be more appropriate if your task is more, you can say, specialized, that may not have a representation in the pre-training or post-training of the model. Okay? So for example, maybe local context में आप कुछ चीज़ करना चाह रहे हैं, पाकिस्तानी context में या कोई और different domain है उसमें करना चाह रहे हैं, तो then you can give examples to guide the model. And here again, no adaptation is occurring. Simply the context, the condition is guiding the output. So this is kind of a math example. So आपने कुछ examples दे दिए, additions की, and then you ask the last one. All of this is part of the prompt. And then hopefully your model would condition on that, learn learn in the sense that adapt its output accordingly to give you the right answer. ठीक है? So all of that what we have seen is sometimes also called hard prompt, meaning that कि आपने खुद ही human generated that prompt, wrote that prompt, and then try to elicit the right information from the model. ठीक है? And how to write that prompt so that we can elicit the right information. So that's called prompt engineering. ठीक है? So strategies that would steer LLM behavior to the desired output. And within this, there is a huge variety, and this is not an exhaustive list. Okay. So instruction prompting is what we have already seen. So role prompting is something that we'll just mention briefly, meaning that you tell the system that I think of yourself in a particular role and then answer this question. So chain of thought prompting, we talked about this briefly as well. So this is reasoning while you answer a question. So you tell it that I want reasons also, so that I can follow what you have answered, whether it's correct or not. So delimiters are formatting instructions, which often help the output. So then, of course, we have already talked about zero and short and few shot prompting, and then style instructions as well. And there are others as well. Okay. So the question was, can few shot lead to overfitting if there are more examples of one class as opposed to the other class? Uh, so that's interesting question, yes. But if you think in terms of technicality, overfitting usually is about parameter adaptation. So in context learning, there's actually no parameter adaptation. So so technically, it's not like overfitting, but it may have an impact like overfitting if you give, let's say, as you said, 75% examples that are positive, for example, and 25% example. Uh, आपका फिर कोई क्वेश्चन था? Okay, I didn't understand your second question, but let me continue my discussion. So if you have 75% examples of one type and 25% of the other, there is a likelihood that it will condition on the 75% more, and it may not give you correct answers for the 25%. So there is a possibility. So this would be something that you will have to try out with empirically. Okay? And since nothing is changing in the model, only your prompt is changing, तो इसको as such overfitting तो नहीं कहेंगे in the technical sense, but इसको study जरूर कर सकते हैं, and then we can think of guidelines that we can provide to end users कि क्या करना चाहिए in the ideal scenario. तो इस पे कुछ स्टडीज मेरे ख्याल से हुई भी हैं, बट अगेन दिस इज एन ओपन एरिया, यू कैन एक्सप्लोर इट इन as part of a research as well. Any other question? You had a second small आपका text था वो मुझे वैसे समझ नहीं आया. So if you want to repeat it or understood it already. So instruction prompting is like zero shot. You give an instruction, a clear instruction, and ask it to do something. So that's we have already seen that. ठीक है ना? So you have explicit direction that you give to the model, summarize in 3 bullet points, and then you give the text that you want to summarize. So that's instruction tuning. So role prompting is actually you tell the system that I think of yourself as a particular role, and then answer it as a role. So you can say that, okay, think that you are a 10-year-old kid, and then try to answer a specific question. तो अगेन इट्स एन इंस्ट्रक्शन, बट उस इंस्ट्रक्शन में एक आपने गाइड दिया हुआ है इसको। ठीक है, सो इसमें कुछ भी रोल में कुछ भी हो सकता है, स्टाइलिंग हो सकती है, गिव मी ए सिंपल आंसर, think of yourself as a as an expert in LLM and so on. तो ये आप उसको इंस्ट्रक्शन दे सकते हैं, देन यू कैन गेट एन आंसर फ्रॉम द सिस्टम. So the example here is you are a cybersecurity expert. Explain how phishing, which is a cybersecurity issue, occurs. ठीक है. So delimiters are kind of formatic instructions that would clearly demarcate to the LLM that this is an end of one section, this is the start of the next section. And I'm not too sure, but some of these delimiters have already been pre-tuned, or sorry, instruction tuned in the models. So that's why they work well. ठीक है, सो इंस्ट्रक्शन, डेटा, आउटपुट फॉर्मेट, कोई और आपकी चीज़ें, मल्टीपल एग्जांपल्स हैं, लेट्स से आप कह सकते हैं एग्जांपल वन, एग्जांपल टू, एग्जांपल थ्री. तो आप स्पेसिफिक इंस्ट्रक्शंस मल्टीपल लाइंस में दे सकते हैं. So the number, as I said, is suggested as a useful delimiter. So most likely it has been instruction tuned, and the model recognizes this as a delimiter. So one of the key benefit is to the model itself. आपका जो क्वेश्चन है वो स्ट्रक्चर्ड हो जाता है. एंड दिस इज ट्रू फॉर ह्यूमन कम्युनिकेशन एज वेल. आप कोई चीज़ स्ट्रक्चर करेंगे तो दूसरे को बेहतर समझ आती है, तो आपने जब स्ट्रक्चर कर लिया तो एलएलएम को भी बेहतर समझ आएगी. ठीक है, सो दिस इज एग्जांपल फॉर समराइजेशन. So chain of thought, we have already talked about briefly before. So this is again an ICL type of thing that you include in the prompt. So you ask the model to explain the answer. ठीक है. So a math problem, like a word problem where you have distances and points and so on, but you explicitly ask solve step by step. So the system would then solve step by step. Again, this must have been instruction tuned in the original model for it to understand. इंस्ट्रक्शन ट्यून पहले हुई होगी इस तरह की, फिर ये अंडरस्टैंड कर सकेगा. ठीक है. सो मैथ के लिए और कॉम्प्लेक्स प्रॉब्लम्स के लिए दिस इज क्वाइट यूजफुल. So we have already talked about few short, zero shot, and few short. Few short में in the prompt you give multiple examples. And again structure कर देंगे तो ज़्यादा बेहतर होगा. So as I said, this would be useful if the model doesn't have much knowledge about that particular topic, or the instruction sometimes is ambiguous. To help the model understand what you want, you can give examples. So again, this is kind of similar to how you try to explain to humans. तो जितना अच्छा आप अपनी चीज़ को स्ट्रक्चर करेंगे, जितनी अच्छी आप प्रेजेंटेशन बनाएंगे, आपकी ऑडियंस उतनी अच्छी अंडरस्टैंड करेगी. सिमिलरली जितने अच्छे तरीके से आप एलएलएम को बताएंगे तो उतनी अच्छे से वो अंडरस्टैंड करेगा. सो ह्यूमंस का फैक्टर है ऑब्वियसली इस एआई एज वी से, सो आर्टिफिशियल इंटेलिजेंस. So composite prompting, of course, you can include multiple ideas in one prompt and then work on those. Okay, so you can combine multiple of the ideas, instructions, as well as few shots and delimiters and role and so on. Okay. So these are generic statements about best practices. Of course, I think all of you must have learned this by trial and error as well, because all of you use large language model in your daily life. ठीक है, and as I said, I've been saying before, these best practices also relate to how one should communicate with other humans. So now we're actually communicating with a machine, but those best practices are still relevant. ठीक है, ह्यूमन टू ह्यूमन कम्युनिकेशन के लिए भी ये रेलेवेंट है. ठीक है, तो आपकी जब टीचिंग भी बच्चे को पढ़ाते भी हैं तो उनको एग्जांपल्स देते हैं या उसको एक्सप्लेन करने की कोशिश करते हैं, उसी तरह की ये चीज़ें हैं. सो नथिंग न्यू हेयर. सो वी हैव सीन ऑलरेडी दिस एग्जांपल्स, ये स्लाइड एडिशनल एग्जांपल्स की. ठीक है, लेट्स मूव फॉरवर्ड. सो व्हाट आर द स्ट्रेंथ्स ऑफ ICL in context learning? No adaptation, of course, in the parameters. So no retraining required, and as such, it is really fast. And it's flexible, meaning that you are not restricted to the task on which you have trained the model. So you can ask the model anything as long as you have given a proper context, a proper prompt. Okay, so of course, computational cost is very low. You just need to run the model with the prompt. What are the limitations? So it is sensitive to prompt variation, and this is why we have prompt engineering. So different prompts might elicit different answers from the system. And this is an open area of research. People are working on these, how best to craft a prompt so that you can get the best answer. Uh, but as I said, theory is limited here. Most of this is empirical in nature. And then, of course, you cannot give a huge context. पूरा आप data set context में नहीं दे सकते, because context windows are limited. जैसे हमने large language models पढ़े थे, context windows can have become very large in recent years, but still they are limited. 32K maximum तक जाते हैं, maybe 32K, maybe 100K तक भी हैं, but those are really big models. But again, those Ks are tokens, not words. तो आप एक पूरा document या multiple documents context में नहीं दे सकते. ठीक है, so if you are not able to explicitly write your instructions, so it will follow that instruction and maybe give a wrong answer. ठीक है? So you have to be careful and your instruction being unambiguous. Otherwise, it will interpret it in an ambiguous way and maybe give a wrong answer. Okay, so the conclusion here is, of course, this is very efficient and you can use it on multiple tasks, uh, but you have to be careful with your prompts, uh, because changes in the prompts may result in different answers. But this has been improving over the years because the models have already been pre-trained and post-trained on some popular prompts, the most popular prompts. The clear example here is, of course, math. एक साल पहले या 2 साल पहले math was really bad. 5+6 भी LLM से पूछें, let's say GPT-3 को, sometimes will give you something else. ठीक है? But one other note of caution here, because आजकल जितने भी large language models आपके पास available है ना online, वो simple generation नहीं कर रहे often times. आपको तो पता नहीं चलता, आपके पास वो इंटरफेस है, पीछे बैकएंड में वो मे बी इट माइट बी writing code, it might be running a calculator, it might be retrieving information using RAG and then answering this. ठीक है? सो इट्स ए मिक्सचर ऑफ थिंग्स। तो आप कहते हैं ना GPT-5 बहुत अच्छा आंसर कर रहा है, इट्स नॉट जस्ट बिकॉज इट जनरेटिंग द नेक्स्ट टोकन कंडीशन ऑन योर टोकन प्रॉपरली, इट मे बी रनिंग अ कैलकुलेटर एट द बैक एंड। ठीक है, सो यू नीड टू बी अवेयर ऑफ दैट एज वेल। So any questions on this before we move on to the next part? So the next part I said was, again, this is for end users. Okay. So next part I've called it fine tuning in general. Okay. So you already have a pre-trained model, post-trained model that you have, and then you want to adapt it to your own specific scenarios. Here adaptation occurs. फाइन ट्यूनिंग में कुछ पैरामीटर चेंज होंगे, सारे भी हो सकते हैं, बट यूजली सारे हम प्रैक्टिस में नहीं करेंगे या कर नहीं सकते, पार्टली करेंगे। बट पार्टली में क्या क्या करेंगे, अगेन देयर आर वेरियस ऑप्शंस। तो लेट्स क्विकली लुक एट दीज एज वेल। So बाय द वे, ये मैंने जैसे कहा था, मैंने जीपीटी से जनरेट किया, बट आई हैव जनरेटेड मल्टीपल थिंग्स, तो मैंने फिर बाद में स्टिच किए हुए हैं। तो बहुत ज़्यादा एडिटिंग नहीं मैंने की, बट मल्टीपल मैंने जनरेट किए थे, तो बाद में मैंने ये जोड़े हुए एक ही फॉर्मेट में, मतलब एक ही फाइल में। तो इट्स नॉट वन क्वेरी, आपको एक क्वेरी नजर आ रही होगी, इट्स नॉट वन क्वेरी दैट आस्क्ड, वो मल्टीपल क्वेरीज, और बाद में मैंने जो स्लाइड्स उसने जनरेट की मैंने इकट्ठी की हैं। ऑलराइट। So what is fine tuning? So you have a pre-trained model and then you adapt it to your own scenario. It could be a separate task or it could be a separate domain, a niche domain or a niche task that is not well captured in the original large language model. And of course, for this, you do need data. So it's not zero shot here. Always it's going to be few shot. Okay? So you will need examples. ठीक है, और इसमें एक और चीज भी है कि जो लॉस फंक्शन है, इट माइट बी डिफरेंट फ्रॉम द ओरिजिनल लॉस फंक्शन ऑफ द मॉडल। इट कैन बी डिफरेंट डिपेंडिंग ऑन योर टास्क। ठीक है, मॉडल का जो ट्रेनिंग का लॉस फंक्शन है वो डिफरेंट हो सकता है। रिमेंबर, यहाँ ट्यूनिंग कर रहे हैं, पैरामीटर्स अडाप्ट हो रहे हैं, सो लॉस फंक्शन की जरूरत है हमारे पास। So the naming might be somewhat off, but this is what I prefer. Standard fine tuning is you have a pre-trained model and then you have some new domain, or yes, you have some new task and you have data for that domain or task. Then you run that data through the model and update a loss function to basically use the loss function to update the model. अब मॉडल में क्या चीज अपडेट कर रहे हैं, इट कुड बी द एंटायर मॉडल, ऑफ कोर्स दैट वुड बी वेरी एक्सपेंसिव अनलेस योर मॉडल इज वेरी स्मॉल। और यूजली इसमें फिर डिफरेंट चीजें अडाप्ट कर सकते हैं आप, मे बी द लास्ट लेयर और ओनली अ फ्यू लेयर्स एंड सो ऑन। सो यहाँ वैसे लिखा हुआ है फुल मॉडल वेट्स आर अपडेटेड, बट दैट्स वन सिनेरियो, बट यूजली आप थोड़े भी कर सकते हैं। ठीक है, so the procedure, I think you understand the procedure. You have data, you have a loss function, feed the data, train the model, adapt the model. You have to have label data. ठीक है, process the data in the format that is required for the model, pass it to the model, update the loss or get the loss, and then using the loss, update the relevant parameter, either the entire set of parameters or some selected parameter. So ये लिखा हुआ है इन्होंने, you need to select which layers to adopt. So you can freeze some layers and adopt some other layers. ठीक है, and of course evaluation is important, so you will be evaluating as well. तो यूज केसेस के बहुत सारे हो सकते हैं, समराइजेशन, ट्रांसलेशन, सिंप्लीफिकेशन, क्लासिफिकेशन। ठीक है, सो नेम्ड एंटिटी रिकग्निशन भी हो सकता है, पीओएस टैगिंग भी हो सकता है, और ये टिपिकली कॉजल मॉडल पे आप यूज करेंगे। नेम्ड एंटिटी रिकग्निशन कॉजल मॉडल का जो नेक्स्ट वर्ड प्रिडिक्शन है, उसके आगे एक जो क्लासिफिकेशन हेड लगा देंगे फॉर नेम्ड एंटिटी। ठीक है, नेक्स्ट वर्ड प्रिडिक्शन पे classification head, and maybe you can just update the classification head parameters, or maybe you can update some preceding parameters as well. Okay, and then of course if you have specialized data for your company or domain like medical or legal or other domain, तो जो आप समझते हैं कि आपका original LLM में नहीं है, तो then you can use standard fine tuning to adapt the model. इसमें pros and cons क्या हैं? So usually you get better performance since you have used labeled data set for your specific task, and usually the label data set is reasonably large, इतना छोटा नहीं होता, reasonably large, so you get good performances. And as such, and also similarly task को भी adaptate कर लेंगे, domain को भी adapt कर लेंगे। let's say आपके पास कोई पाकिस्तानी कोर्ट्स का जजमेंट का डेटा है, उस पर आपने अडाप्ट करना है, you use all of that data, then you get good adaptation. What are the negatives? So of course it's going to be expensive computationally, memory wise as well. So models are very large, you have to train the model, adaptation chal rahi hai, and depending on what you are updating, it can be quite expensive. Okay, there's another issue which is called catastrophic forgetting. So this is an issue if you standard fine tune a large language model on some domain using input output data, labeled data, it might forget what it had already remembered in pre-training or post-training. So that is called catastrophic forgetting. So let's say if you take a model, let's say GPT-4 आपने उठाया, of course उसका कोई छोटा मॉडल ही आपने उठाया होगा, छोटा मॉडल लिया GPT-4 का, और उसमें आपने अपने let's say मेडिकल डोमेन के ऊपर फाइन ट्यून करने की कोशिश की। Once you have done the fine tuning, you might notice कि उसने बाकी सारी चीजें सब कुछ भूल गई हैं उसको। आप उसके ऊपर जनरल नॉलेज की क्वेश्चन पूछें तो you might not know that. So this is called catastrophic forgetting. And this is an issue that may arise if you do standard fine tuning. And this is also an area of research. एक recent master student ने भी इस पे काम किया था. We have a paper on it. Of course, it's not a very high flying paper, but obviously decent work था. So, so it's an area that, as I said, you can work on. So now let's move on to the standard fine tuning. So there's another fine tuning which is called prompt based fine tuning. Again, the naming might be off in the literature, but this is more common and this is how I like to see it. So prompt based fine tuning may, this is usually fine tuning is based on the prompts that you give. ठीक है, जो prompts हमने in context learning में देखे थे ना, it's based on that. It's not based on input output examples that we saw in standard fine tuning. So usually the base LLM is frozen, only some parameters are adapted, and those parameters are associated with the prompts. So obviously if you're updating only a small number of parameters, you can increase your adaptation process. So computational time and memory requirement would be much better. So ओके, ये हार्ड प्रॉम्प्ट की स्लाइड यहाँ आई हुई है, बट यू कैन थिंक ऑफ हार्ड प्रॉम्प्ट एज द प्रॉम्प्ट दैट वी सॉ इन द प्रीवियस स्लाइड। ठीक है, इसमें कुछ अडाप्टेशन नहीं हो रही। सो इट्स प्रॉम्प्ट लाइक प्रॉम्प्ट इंजीनियरिंग जो हमने पिछली स्लाइड में देखी थी। ठीक है, सो मैनुअली रिटन नेचुरल लैंग्वेज इंस्ट्रक्शंस। ठीक है, सो दिस इज इन कॉन्टेक्स्ट लर्निंग दैट वी सॉ इन द प्रीवियस स्लाइड्स। इसको हार्ड प्रॉम्प्ट भी कहते हैं। So let me skip this. We have already seen this. So soft prompt, this is where actually adaptation occurs. So इसमें कई variety है. People call it soft prompt एक तरीका है, एक prefix tuning एक तरीका है, and then there are others as well. So in soft prompt, you have continuous vectors that are learnable. ठीक है? And they are usually associated with specific positions in the input, in the prompt. सो इफ यू रिकॉल, जो फिजाद ने लेक्चर दिया था उसमें मास्ट एक टोकन था। उस मास्ट टोकन का जो इनपुट एम्बेडिंग थी, सो दैट इज द एम्बेडिंग दैट इज बीन अडॉप्टेड। ठीक है, ओनली वन एम्बेडिंग उस टोकन की, उसको हम अडॉप्ट कर रहे हैं गिवन सम इनपुट आउटपुट एग्जांपल्स। सो एज दे से इट्स अटैच्ड टू द इनपुट टोकन। यूजुअली इनपुट टोकन, इनपुट आपके पास वेरियस टोकन्स हैं, उसके आगे एम्बेडिंग लेयर होती है। एम्बेडिंग लेयर में उसका एम्बेडिंग्स आ जाती हैं। जो मास्क की जो एम्बेडिंग है उसको हम अनफ्रीज कर देते हैं, सिर्फ मास्क की एम्बेडिंग को अपडेट करते हैं। सो रिमेंबर इन द एग्जांपल दैट फिजाद शोड यू, सो यू हैड ए सेंटिमेंट स्टेटमेंट लाइक द मूवी वाज गुड। उसके बाद फिर ऐसे दिस इज ए मास्क मूवी। मास्क का जो टोकन है, वी वांट द वर्ड गुड देयर, तो उस टोकन को हम अडॉप्ट करते हैं सो दैट वी कैन गेट द वर्ड गुड देयर। So simply one vector is being adapted. You can, of course, you can have more than one vector, but that's an example in which there is one vector. So this is soft prompt in general, where you have vectors attached to the input that you adopt. और इसमें भी of course input output examples चाहिए आपको. So you will have to give multiple examples like this. कि आपके पास sentiment है, फिर this is a good mass movie, this is a mass movie, this is a mass movie, and so on. Multiple examples आप देंगे so that it can learn it. ठीक है, इनिशियलाइज तो यूजली रैंडम होगा। So you concatenate with tokenized input, you can usually concatenate, but usually it's just update the embedding associated with the input. ठीक है, so you only pre-train those vectors, those embeddings. And of course, you need to validate and deploy. So again, थोड़ी सी नेमिंग में डिफरेंस है। So pre-tuning भी आप कह सकते हैं prompt tuning. So pre-tuning or prompt tuning, in this you again have learnable parameters or learnable vectors, but these vectors are not part of the embedding layer, they are part of the मॉडल। मॉडल में आपके पास ट्रांसफॉर्मर ब्लॉक्स होते हैं, और यूजली जो जैसे प्रीफिक्स ट्यूनिंग का जो मेथड है, उसमें जो अटेंशन मैकेनिज्म को आप ऑगमेंट करते हैं, उसमें एडिशनल आप ऑगमेंटेड वेक्टर्स डाल देते हैं जो सिर्फ अपडेट करते हैं। ठीक है, सो अगेन दिस इज अपडेटेड बेस्ड ऑन वेरियस प्रॉम्प्ट्स, इनपुट आउटपुट प्रॉम्प्ट्स दैट यू गिव, नॉट ऑन इनपुट आउटपुट एग्जांपल्स। ठीक है, सो दिस इज द प्रीफिक्स ट्यूनिंग दैट आई टॉक्ड अबाउट। सो जो prompt tuning की बात की है, prefix tuning, both of these are kind of similar, different names हैं. In some case you might see one name as opposed to the other name. So in both of these cases you inject learnable parameters into the model. not just the embedding. ठीक है, और प्रीफिक्स ट्यूनिंग में एज यू कैन सी इन दिस स्लाइड हमने ये पैरामीटर्स जो अटेंशन मैकेनिज्म में ऐड किए हैं, द की वैल्यू कैलकुलेशन में ऐड किए हैं। ठीक है, और जब हम अपडेट करेंगे सिर्फ जो नए पैरामीटर्स हमने ऐड किए हैं वो अपडेट करें, बाकी फ्रोजन है। As it is obvious, since you have more parameters, more vectors to learn, and they are inside the model, so these are more expressive. ठीक है, but but then of course you probably need a bit more data to train this. ठीक है, सॉफ्ट फॉर्म में भी आपके पास dozens of examples से ट्रेनिंग हो जाएगी, इसके लिए आपको मे बी यू नीड 100 of examples. ठीक है, सो the nitty-gritty details जो math है you can find it on the literature, but I'm not going to cover that here. But as I said, it is part of the attention computation. जो हमने attention computation discuss की हुई है पहले. So how we compute the the value vectors, the key vectors and the query vectors. Usually the key and value vector जो inner product लेते हैं. Sorry, the key vector and the value vector. Value is output. इनमें आप update करते हैं. And then of course you only update these parameters, the new parameters. So this slide gives you a comparison. So hard prompt of course वो in context learning है. So this manual, it's usually brittle, fails or works, or and there is no training. So if you talk about soft prompt, which is maybe in the embedding layer, okay, so you basically learn the embeddings and maybe a few examples से आप उसको adapt कर सकेंगे. You don't need too many examples. So prompt tuning. So again here the the vectors are inside the model. So this is you can say a variant of not really soft prompt, but maybe the variant of prefix tuning. Prefix tuning. So injected in transformer layers, and again, you adapt this with your training examples, and you probably need more examples here. Okay. So of course, use cases, whatever is new on which the original large language model does not work well. So you will probably use these tuning techniques. So classification with limited data, that's a very common example. Okay. So specific applications in conversational agents would be another case. So domain adaptation is specific domains, medical, legal, finance, industrial, whatever. And multiple model task sharing. This is actually an important point. So जितने भी हमने prompt based techniques देखी हैं, so you have your one base model which is fixed. अब let's say मैं prefix tuning की बात करता हूँ. तो prefix tuning में आपका base model fixed है और some prefix parameters हैं. Maybe 0.01% of the whole model. वो आपने अडाप्ट किए maybe for task A and you can maybe save it. टास्क बी के लिए भी अडाप्ट करके वो भी सेव कर दें, टास्क सी के लिए भी अडाप्ट करके सेव कर लें. सो नाउ यू हैव मल्टीपल टास्क दैट यू कैन यूज टू सॉल्व. लेट्स से इफ यू वांट टू सॉल्व टास्क सी के पैरामीटर यूज करके उसमें एम्बेड कर दें एंड देन यू यूज द मॉडल. आपने प्रॉब्लम बी सॉल्व करनी है, बी के पैरामीटर उठाए उसमें डाल दिए और सॉल्व कर लिया. सो मल्टीटास्किंग बिकम्स रिलेटिवली इजियर. ठीक है. By the way, ये जो small number of parameters and multitasking का concept, this is also true for low rank adaptation. Lower rank adaptation can be done for standard fine tuning, which we discussed earlier. और उसमें ए और बी पैरामीटर्स हम सिर्फ अडाप्ट करते हैं फॉर द पैरामीटर डब्ल्यू। सो उसमें भी हर डिफरेंट टास्क के लिए सिर्फ ए बी अडाप्ट कर लें और आपने उसके लिए यूज करना सिंपली उसके अंदर ऐड कर दें, यू यू सॉल्व द प्रॉब्लम। ठीक है। सो मल्टीटास्किंग इस तरह आसान हो जाती है। You can build models for multiple tasks by just saving these additional parameters. AB for low rank adaptation और prefix tuning में उसके appropriate prefix vectors जो थे वो आप सेव कर लें। So this is, I think we have already discussed most of this. So pros, of course, is efficient, allows multiple tasking, and so on. The cons are maybe it's underperforms usually फाइन ट्यूनिंग, स्टैंडर्ड फाइन ट्यूनिंग, दैट्स ऑब्वियस बिकॉज स्टैंडर्ड फाइन ट्यूनिंग में ज़्यादा एग्जांपल्स आप यूज देते हैं और मॉडल को ज़्यादा ट्रेन करते हैं। ठीक है। मेरे ख्याल से ये एसेंशियली एंड हो गया। सो आई थिंक आई एंड हियर। ओके 254। ओके ऑलराइट। So I think that is essentially the content that I wanted to cover in this course. So we will not be adding any new content after today or after this point in time. So so all right. So on Wednesday, we have our final quiz at start of class. So I will be present in class as well. So we will briefly discuss the final exam on Wednesday. So maybe I just take 5-10 minutes of your time on some general ethics. I think that will help you in general as human beings as data scientists as well as uh, in your respective jobs. So and by the way, this would extend to the idea of the whole idea of, I think you might be following the debate of super intelligence and artificial general intelligence and how they might adapt or change the world around us. तो उसमें भी ये issues ethics के और उसके आते हैं। तो let me first start with the general things. So I think there are two important concepts and traits that we should try to inculcate in ourselves to learn to lead a meaningful life. So one is sincerity. Okay, and the other is competence. So in whatever endeavor you undertake, so keep these two traits in mind. So whatever you do, do it with sincerity. And what does sincerity means? It essentially means that your purpose, your goal uh, should be in line with general ethics and in the most simplest sense. So let's say if employer you're working for an employer, so you should uh, do the work that you desired for the employers because he's paying you. So that's sincerity. Uh, and if you're doing some of your own work, so you should always design products and services that are in general beneficial to human beings in general, to the planet, to other people. So ये goal sincerity आपने रखनी है. So you don't want to do things that are uh, harmful, that can potentially lead to destruction or other harm around us. So sincerity is very important. So the other major trait that I mentioned here is competency. So whatever you do, we need to excel in it. So whether it's a job, whether it's a It can be anything else as well, being a father, for example, or being a mother, for example, or uh, contributing your time and volunteer effort. So whatever time slot that you ordain for yourself, try to excel in that, try to master that task. Okay? In other words, you need to put in the effort. Effort डालनी पड़ती है. ठीक है? So competency, make yourself or try to make yourself the best in whatever you are doing at the present point in time. So that competency, and then do it in the right spirit, that sincerity. So these two things, if you keep in mind in all of your endeavors, I think it will take you a long way. ठीक है? ठीक है? And then there are a couple of other things. Of course, there are many traits that are relevant, but I've tried to highlight a few of them. So दो तो मैंने highlight किए, sincerity and competency, and always keep this in mind whenever you do anything. Then a couple of other things, humility. So humility is a trait that I think we should develop in ourselves. We need to be humble. Arrogance is counterproductive in almost all scenarios. So if you think of anything that you have, you'll always find someone who is better than you. Okay? You will almost always find someone who is better than you in whatever thing that you can think of. And of course, we need to humble ourselves in front of our Creator, Allah subhanahu wa ta'ala. So that's a very strong message to us that we need to humble ourselves. So we are just like a small speck in the world. So, and our contribution, of course, is significant, but it's not that significant that we will become arrogant. So humility is important. So humility in the context of dealing with other human beings, and humility also, especially in the context of our Creator. Okay? And this, of course, humility should naturally lead to gratefulness. So whatever you have, I think it's wonderful. So you should be grateful for that. Okay? So so these are, I think, four traits that I think are essential, and we should work to embody these in our daily lives, in our jobs, in our personal interactions, and and it will take us a long way. So sincerity and competency in any endeavor that we are doing, and then general traits, we should always keep ourselves humble, and then we need to be grateful. Just another comment. Remember, I said you need to put in the effort. So effort is essential. You want to excel in anything, you have to put in the effort. You have to do good in something, you have to put in the effort. But the point is, putting in the effort may not always lead to success. ठीक है? So success जरूरी नहीं है कि हमेशा आपको मिल जाएगी. आपने बड़ी मेहनत की और sometimes maybe वो मेहनत कामयाब नहीं हुई. So that is fine. So that is fine. So we don't need to fret over issues. So failures are part of our learning process. So effort आपने डालनी. Maybe we will fail sometimes. So that's fine. We may not get our reward in this world, but certainly the next, especially if you had the right intention. Sincerity आपकी सही थी, so definitely you will be rewarded in the next. ठीक है? So effort and success में हमेशा एक one-to-one relationship नहीं है, but हमने effort फिर भी डालनी है. So that is one thing that I wanted to highlight here. Sure. ठीक है. So I think uh, मैंने I think you might be following the issue of artificial general intelligence or super intelligence. So just a few comments on this. I think it may be for those who go on to work with companies like OpenAI or Google. Yeah, you need to keep this point that I mentioned earlier in mind. So जो भी चीज़ हम develop कर रहे हैं, we should develop it for the benefit of humanity. ठीक है? And you might have seen the debate कि ये super intelligence हो जाएगा तो it might destroy humanity. So that is a possibility according to my understanding. But मेरे ख्याल से बहुत ज़्यादा हमने इसके ऊपर worry भी नहीं करना. So it is a possibility, yes, it is a possibility. I think it is a possibility, but uh, human beings are resilient, so they can overcome this. It's not going to be an issue. But more importantly, as computer scientists, we should design these systems that such issues do not arise, or there is no possibility of such issues. So generally, we need to design these systems in narrower domains. So let's say if you want to, आपने AGI use करना है या super intelligence use करना है, but use it for a much more narrower domain, like driving a car or driving an aeroplane or other things, rather than giving it open access to everything. So that would be a major issue. ठीक है? And of course, this debate is quite broad. Philosophy can be चले जाती है and so on. Uh, but the general takeaway is that there is an issue, as far as I know. It's a concern, but we do not need to be overly क्या लें कि overly परेशान नहीं होना चाहिए. So we should continue working in our respective domains according to the things that I mentioned. Sincerity honi chahiye, competency honi chahiye, keep ourselves humble, be grateful, put in the effort. ठीक है? So, okay, I think with that, I think I will stop here. Any questions? So as I said, on Wednesday, our physical class hogi, online nahi hogi, quiz hai pehle, and then we might spend 20 minutes after that discussing the final exam. And if you have any specific questions, we might discuss that. So the question है तो आप बेशक ले आएं Wednesday को, and inshallah we'll do that on Wednesday. ठीक है? So any questions?